We had reached to part B of question 9 of the January 2025 CSEC Mathematics paper 2. And I had asked you to work it out as your homework. Have you done that? What are your answers? Let us see what is going on here now. It says, alright, before I read it, let me just copy it and paste this thing over here. Okay, good. It says here, two ports, E and G. So here you have port E and you have port G. Are on level ground 245 kilometers apart. You can see the distance marked here. The bearing of E from G is 302 degrees. A ship is anchored at F. So you're looking at the bearing of E from G. Good. A ship is anchored at F. Right here. Some distance away from G. On a bearing of 228 degrees. That means the bearing of F from G is 228 degrees. Angle EFG, equals 52 degrees. You can see it here. This information is shown on the diagram below. On the diagram above, insert the angle 228. The bearing of F from G. Well, you could just insert both angles. It's two bearings they give you. So just put them in. So you have the bearing of E from G. When you say the bearing of E from G, when you say from G, that is where you're going to draw your north line. Well, it's drawn already. And your arc. Bearings are measured from the north in a clockwise direction. So you end that arc on the straight line between E and G. And that angle is 302 degrees. Alright? Now, here. The other bearing, E from G, they ask you to write it down, to insert it, 228 degrees. So, in that case, you have your 228 degrees right here. Alright? So you have the two bearings there. You would need to put the 302 because they didn't really ask you to do it. Because I know I'm expecting us to be required to use it in a calculation. I just put it up there for the 302 part. Alright? Now, the 302 degrees. Okay, good. Now, it said determine the value of angle determine the value of angle FEG. Angle FEG. Okay. FEG would be this angle here. You want this angle FEG. How would this go now? Okay. One thing you do. You need to find at least two angles in this triangle in order to get FEG, a third angle. Now remember, if you swing right around and come here, you go 302. If you swing right around and stop here, you go 228. So what is it from here to here? That angle EFG, FG would be equal to 302 minus 228. That is what you would get, right? So 302. So you have your 302 minus 228, giving you 74 degrees. So you get 74 degrees. All right. So this angle here now is 74 degrees. Now you need this. So you know what to do now. You know that everything add up to 180, so 180 minus, so you take 52 away from the 180 and you take off 74 from the 180, right? So if you have 180, you take this and you take this off, what you have left is this, is equal to FEG, alright? So in that case, let's do our calculation using our calculator here. So you have 180 minus 52 minus 74 equal 54 degrees. So that is 54 degrees. Well, I write this like this, almost make it look like 540. It's 54 degrees, alright? Good. So you have 54 degrees there. Now, let's see what else happening here. So you angle FEG. What else they want from us? Calculate GF, the distance the ship is from port G. Alright. Let's copy this thing and paste it over here. Let's drag it down. So calculate GF. GF. Okay. So they want this distance then. Alright. Now, as you see, this is not a right angle triangle. And if you did not know what type of triangle it was, do not assume it is a right angle triangle. You see the sine equal opposite over hypotenuse and the cosine equal adjacent over the hypotenuse and the tangent equal opposite over the adjacent and the Pythagoras theorem. Those can be used for this. This is not a right angle triangle. Alright? You would have to use the sine rule and the cosine rule. Now, the sine rule and the cosine rule, those would be on your formula sheet. Which one? They call it a table of formulae. Alright? List of formulae. They call it. Now, part of this is blacked off, but sine rule and the cosine rule. You have small a, which is a length over the sine of the angle opposite to it, equals small b over this small length b. Small b is the length b over the sine of the angle b. C over sine c. The side c over the sine of the angle c. You have it here, sine rule, and then the cosine rule. The small a, b, and c are the sides, and then big A is the angle opposite to the side. But we'll see. We'll see how it works out here. Now, you should find GF. Let's try the sine rule first. Sine rule is a bit easier to deal with, less complicated. Now, if you have this as angle E, big E, this would be the side small e. Big G, side small g, and big F here, side small f. Alright? So, you have E over the sine of big E equal, so remember, even though on the formula sheet they use A, B, and C, A over sine A equal B over sine B equals C over sine C. In this case, it's not any A, B, and C you have. It's E, F, and G, but the same principle applies. Alright? E over sine E equal F over sine F equal G over sine big G. Alright? Now, here, E is what we want, so we use it. E is the same thing as FG, you know. E over sine 54 equals, and then use the one that's given. It's safer because if you use an angle that you had calculated, what if you got that angle wrong? Then it would lead to the next answer being wrong and so on. Alright? Now, here you have small f, which is 245 over the sine of big F, which is 52. So you can do your calculation now. So the side B is equal to 245 times sine 54. It's 54, right? 54 over sine 52. So E is equal to. Let's use our calculator and figure that one out. Alright, so 245, oh, let me clear the calculator. 245 times the sine of 54 equal over the sine of 52 equal 251.53. 251.53. So, the distance GF is 251.53 is kilometer, right? They have it in kilometers, the distances. So 251.53 kilometers. All right. Now, where were we? We passed that stage already. Okay, good. The angle, then the distance. After that, let's say indicate the point H on the line EF such that GH is the shortest distance. Alright, H and EF so that GH. Let me just copy and paste it over here. Okay, oh, it's covering the other one. I don't want to cover anything. Let me pull this down and this thing as well. All right. Indicate the point H and EF. So let's erase some of these things. Don't want to have the diagram, the screen crowded too much. Let me just erase some of these things that I had here. All right. So indicate the point H on EF. So you have EF here. There's some point H. Where is it? Somewhere along here. All right, along EF. such that GH, so the point is G, no, the point is H. H is somewhere along here. Oh, it says EF, right, it's EF. Yeah, it's somewhere along here. I was thinking it was up here. It's EF they're talking about. So that point is somewhere along EF. Such that GH, from G to H, the point H, alright, is the shortest distance to EF, and determine the distance. Now remember, if you do that, if you pass a certain point, the line will be getting longer. If you move towards from E to F, the line gets shorter and shorter and shorter, but at some point it got to get longer and longer again. Now, there's a certain point at which it's shortest. You know what the angle would be between that line from G to H and the line EF? It's going to be 90 degrees. 90 degrees it will be. You see that? Now, determine the distance GH. Alright. The distance GH. Now here we will concentrate on this triangle here. You can see that triangle. It's a right angle triangle. You have 90, you have 54, so you can find the other angle. What angle is this? Let's see. If we say we have this angle plus this angle plus this angle give us 90, it give us 180, then 180, you take 54 off 180, and then take the 90 off it. What you have left is angle EFG. This angle right here, EFG. So it's EFG. Alright? Now, 180 minus 90 is going to be 90 minus 54 now. Borrow 1 from 9, you get 8. It's 10. 10 minus 4 is 6. 5, 6, 7, 8. That's 36 degrees. So you see that? So you have the 90 minus 54 gives us 36 degrees. Now, here, I want you to determine the distance GH from G to H. So here, when you consider it, you have the angle, the side that is opposite to it, and you have the hypotenuse. So in this case, you would not have to worry about using the cosine rule, because you now have a right angle triangle. So you say sine 54 degrees is equal to the opposite GH over hypotenuse 245. So GH is equal to 245 sine 54 is equal to, let's calculate that. 245 times sine 54 equal 198.21. 198.21 kilometers would be that distance. All right, 198.21 kilometers. So you see that? And remember, you should look to see if I made any errors and let me know. That's it for question 9. Alright, good. So in the next video, we'll start looking at question 10. So I'll see you.